So this what in this lecture what we are going to see is we'll be discussing 4-point mode measurement, basically the conductivity measurement. So and then followed by the derivation of the relation for the resistivity. Right? So here four probes stands for basically we have four probes and we will be measuring the conductivity using the probes. So when you take the probe, right? So so we will have its own resistance that is called as REE or wire resistance. When the probe touches the sample, it will have some other resistance that is called as the contact resistance. And the sample, when the current passes through the sample, some resistance will be there that is called as spreading resistance. Right? So the four probe measurement setup. So we basically have four probes in the probe 1, 2, 3, and 4. So in the outer probe, that is probe 1 and probe 2, we will be connecting to the current source. So and we will be sending current through this probe 1 and the probe. That means, let us say you are sending current through probe 1 and measuring, basically taking the current out to the probe 4. So this is basically current passes here and goes to the sample and leaves the sample through this junction. Therefore, the outer two probe will act as the current path or current passage. The inner probe, so because of this current passage or current flow, we have to measure what is the voltage of these probe 2 and 3. So to measure the voltage, we will be connecting the voltmeter across probe 2 and 3. Okay. So here we will be connecting the current source meter and then we will be passing the current and then in the inner probes that is 2 and 3 probes, we will be connecting the voltmeter to measure the voltage. Right? This is the basic setup. So apart from that, so these probes, right? We have four probes. All the probes are kept with equal distance. That means the distance between these two probes is S and distance between 2 and 3 is S and again 3 and 4 is S. That means all the probes are kept with equal spacing. This is the actual setup. So now we will see the equivalent diagram of this you know four probes. Before that, what we will do? So because of this kind of arrangement, what we have is we basically have when the current passes through this probe 1 and the probe 4, so there won't be any current that is flowing or very minimal amount of current will be flowing through probe 2 and 3. Right? Through 2 and 3, the current will be flowing very small numbers. That means the current amount will be very small or it is completely negligible amount. So that is because the voltmeter connected to the probe 2 and 3 will offer high input impedance. High input impedance. I input input UP input impedance. That means this voltmeter will show high input impedance. So what is that impedance value? Typically greater than, right? Typically this value will be actually this input impedance value will be greater than or equal to 10 power 12 ohms. So you can think of this very huge amount of resistance that offered but because of this the voltmeter connected to these inner two probes. So therefore, the current cannot flow in this direction. It faces huge amount of impedance. That means the current flow will be very small or is negligible. So therefore, this method is having the advantage over the two probe method. So that means what happens now? So because of this, the the contact resistance due to the contact resistance and the wire resistance contribution will be less. That means the total resistance what we write is R is equal to 2 times wire resistance plus 2 times the contact resistance plus spreading resistance. So here, this term, the wire resistance and contact resistance value will be smaller because of this reason. So therefore, whatever the resistance that you get is primarily due to the sample uh, voltage drop or sample resistance. So this is the advantage of the four probe method. And here, this is the equivalent circuit of the four probe method. So here we have similarly the sample. This is called the device under test, or simply we can say it is a sample. And this is connected to the voltmeter and then ammeter, basically the current source. The current will be flowing in this way, and this wire will have some resistance, that is RW, and this wire will be contacting a sample at, this sample, and the wire interface is giving the R contact, that is contact resistance. Similarly, the other end of the current source will be connected to the sample, and that wire will have some resistance, that is RW, and that wire will be having some contact with the sample, that is again contact resistance or C. Similarly, the voltmeter that we connected in the inner probes, that is in probe 2 and 3, will be having some wire that will have the wire resistance, and that wire will be making contact with the sample, that is again the RC, that is the contact resistance, which will form here. The other end of the voltmeter is again connected to the sample, so the wire, that other wire will have the wire resistance, and then the wire will make contact with the sample, that is again the contact resistance. Therefore, these two, these two, these two component and these two component, and then sample resistance, all these will be the total resistance that you will get it in this kind of the measurements.